Section 8-9, Quadratic Equations, Perfect Square Trinomials. Our essential question is, how do you factor a perfect square trinomial? We have one new vocabulary, and that's perfect square trinomial. A perfect square trinomial is a factoring pattern in which, when you factor it, both of your binomials are the same. They're exactly the same. So, one perfect square trinomial would be a squared plus 2ab plus b squared, and that would equal a plus b times another a plus b factor, which could be simplified as a plus b quantity squared. So it's a perfect square because when you factor it, the two binomials are exactly the same, so you can write them as a square. The other one looks similar. It just has a minus on the middle term. So both of the binomials have minuses. So it will be a minus b quantity squared. So what we're going to be doing today is we're going to be using all of the methods that we've learned for factoring so far. And we're going to factor, so it's a good review lesson. And then we'll examine the binomials that we get and determine if it is a perfect square trinomial or not. So here's our first example. On this first factoring problem, I want to remind you that we don't have to factor by grouping here. Because to get that first product of x squared, the only way that these binomials can start is x times x. Then, to get our product of 9 and our sum of 6, that will happen for 3 times 3. 9 times 1 is also 9, but that will give us a sum of 10. So the one that works is 3 and 3. So both of these binomials get positive 3's. And I will show you that this works by foiling. So my first product was x squared. Outside product, x times 3 is 3x. Inside 3 times x is also 3x. Last, 3 times 3 is 9. So these two terms in the middle are the same. They add together to give us 6x. So my answer is correct. So I'm going to say, yes, this is a perfect square. Yes, this is a perfect square trinomial. And when I factor it, I get x plus 3 quantity squared. Okay, my next one, factoring the same way.
Ms. Geyer, call 6805. Ms. Geyer, 6805.
X squared is x times x. I need a product this time of positive 16 and a sum of negative 10. So 16 can be 1 times 16, 2 times 8, or 4 times 4. Because my sum has to be a negative, I need both of these to be negatives. A negative times a negative is a positive. So the one that will give me the sum of negative 10 is in the middle. So I need negative 2 and negative 8 in my binomials. Now I can FOIL this. X squared minus 8x minus 2x and plus 16. Adding together negative 8x and negative 2x, they're both negatives, so it would stay a negative. Negative 10x is correct. So on this one I can say, no, this is not a perfect square because I got x minus 2 and x minus 8. They're not the same. So you can factor it, but it's not a perfect square trinomial. Okay, my next one, because there's a coefficient in front here, I need to factor by grouping. So factor by grouping. So it's a little bit more complicated, and you can honestly use grouping on those easier ones if you need to. So I need a product of A times C, and my sum is still B. So my product is 9 times 4, or 36. My sum is 12. So I could write all of these factors of 36, but I know that the one that's going to give me 12 is 6 times 6. So you don't have to write all of these factors. If you can think of the factor pair right away, it's going to work. Now, remember how grouping works. It's this term in the middle that I'm going to be changing. So 9x squared plus 6x plus 6x plus 4 is what we need to use. Now I group together my terms, and I take out their greatest common factor. 9 and 6 can both be divided by 3, and these terms have an x in common. So I am factoring out 3x. Now 3x times 3x is 9x squared, and 3x times 2 is 6x. So what I have left in my binomial is 3x plus 2. I match that for my other terms, and that means I have factored out 2. 2 times 3x is 6x, and 2 times 2 is 4. Now I can write my answer. I take this binomial for my first one, and then my second one is what I factored out, which you may notice is another 3x plus 2. So that means that this is a perfect square trinomial. So I need a little room here. So I'm going to say yes, and it's 3x plus 2 squared, because both of my binomials were 3x plus 2. Okay, next one. Product, A times C, so 25 times 1 is 25. Sum, negative 10. 5 times 5 is 25. Because I need it to be negative 10, I'm going to make both of them negative. So negative 5 and negative 5. So 25x squared. I split my negative 10x into 2 negative 5x's. Like that. I group, and I can take out as a greatest common factor 5x. 5x times 5x is 25x squared, and 5x times 1 is 5x. So 5x minus 1 is what I need to match. So now, if you look at the terms up above, I didn't put parentheses around them because of this minus. So it's a negative 1 that I would have to factor out. Negative 1 times 5x is negative 5x, and negative 1 times negative 1 is positive 1. So I'm always looking at distributing here to make sure that it equals the terms up above it, distributing them, okay? Now I can write my binomials. So the first one from in my parentheses, and then the second one, what I took out as the GCFs, and they do match. So this one I'm going to say yes, it's a perfect square trinomial, 5x minus 1 squared. So both of these were perfect square. Okay, now our problem has changed a little bit. You may notice the equal sign. So that means that we're going to factor, and then after factoring, we have to use the zero product property to figure out what x is equal to. So we're not factoring and then stopping. We're factoring and then solving for x. So I'm going to take this negative 64 and put it on the correct side. Because if you are going to use the zero product property, that means your product has to equal 0. So not equal negative 64, but equal 0. Now, on this problem, if we do our product and sum, we are going to get some huge numbers. So a calculator probably comes in handy here. So 9 times 64 is 576, and the sum is negative 48. Well, I happen to recognize that that's a perfect square for 24. You may not know that one. So negative 24 times negative 24 is positive 576. You may also notice that the number 9 is a perfect square, and so is the number 64. So you could have expected 576 to be a perfect square. Now, 9x squared minus, I'm splitting this into negative 24x and another negative 24x, like that. Then I group together my first two terms. I can divide 9 and 24 by 3, so I take out 3x. What's left inside? 3x times 3x is 9x squared, and 3x times 8 is 24x. So now I repeat that, 3x minus 8. And if I look at my terms up here, I have divided them by negative 8. Negative 8 times 3x is negative 24x. Negative 8 times negative 8 is positive 64. So my binomials are both 3x minus 8. The good news about that is I don't have to solve both of them. I'm only going to have to solve one of them to figure out what my 0 is. So I set one of them equal to 0 over here, and I solve it. Add 8 on each side, 3x equals 8, and then divide by 3. So x equals 8 thirds. I don't have to solve both of them because they would give me the same answer. All right, so this one, yes, it was a perfect square trinomial, even though they weren't asking that. So it helped us in our solution. We only had to solve for one. Okay, next one. Look at where the equal sign is on this one. I'm going to have to move both of these terms. They are on the wrong side. So I'm really dealing with 3x squared plus 5x plus 2 equals 0. So I need a product of a times c, which is 6, and the sum of 5. So 3 times 2 is 6. 3 plus 2 is 5. So I'm going to keep my 3x squared, split my 5x into 3x and 2x, and factor. So GCF, the GCF on the first two terms is 3x. 3x times x is 3x squared, and 3x times 1 is 3x. So I repeat that binomial, and what has been factored out of my last two terms is a 2. So I have x plus 1, and out here, 3x plus 2. So this is not a perfect square. Nope, not a perfect square. So I'm going to solve each one of these. And I'm going to get two different solutions. So subtract 1 on each side, and x equals negative 1. Or subtract 2. 3x equals negative 2. Divide by 3. X equals negative 2 thirds. So two completely different solutions. X equals negative 1, or x equals negative 2 thirds. Our last slide. This one will factor pretty quickly. X squared means x times x. And I need product 36, sum 12. I think we saw this one before. 6 times 6 is 36. 6 plus 6 is 12. So I add 6 on each of my binomials. Remember, you can always factor this by grouping. You can always FOIL it to check and make sure you are correct, okay? Now, if I solve each of these, I'm really gonna only have to solve one of them because they're the same. So x equals -6. And this one is a perfect square. They weren't asking for that, but the factors are the same. It's a perfect square trinomial. So I only get one solution. Okay, this last one, you may notice there is an x to the third. It's not a quadratic, it's cubic. So we actually need to factor out that extra x first before we can get our binomials. So this is what it would look like if you factor out that x. Now I need a product of a times c, so 30, and a sum, -11. So 6 times 5 is 30. I need a -11, so they're both negative. So -6x and -5x. So I'm going to leave this x out here alone for a minute, and I'm just going to factor my trinomial. Okay, so if I group these, I'm not grouping the other ones yet because of the minus. I can take out a 2x. So what would be left? X minus 3. So I need another x minus 3 over here. What has been factored out will be a -5. -5 times x is -5x. -5 times -3, +15. Now my binomials would be x minus 3 and 2x minus 5. I have my equals 0, and now I need to bring this x back down. Because what that x does is that x actually gives us a third solution. Because our original equation was cubic, a degree of 3. We can expect to get 3 solutions. Now, if I set this one equal to 0, there's no solving involved. It's just telling me that there's a 0 at 0. So this cubic function, if we graphed it, goes through the origin. The next one, I set equal to 0, and I get x equals 3. And then the last one, 2x minus 5 equals 0. Add 5, and 2x equals 5. Divide by 2, x equals 5 halves. So we have 3 solutions here. So 0, 3, 5 halves for our final example. You should be able to write a summary now. No, this one was not a perfect square. Answer the essential question, and please make sure that you use complete sentences and detail.